What do we got tonight?
I have a review for my test.
Okay.
So all I really need help on is um stuff with normal distribution and standard deviation,
Okay.
and then expanding a binomial.
Okay. I think I can help you. It depends on the normal and distribution, what kind of questions they're asking you, but go ahead.
So for the deviation, it says what percentage of the area under a normal distribution curve.
Sorry. Go ahead.
Okay. What percentage of the area under a normal distribution curve lies within one standard deviation of the mean?
Okay. So what they're talking about, there's the mean. There's x mean plus one standard deviation. There is x bar minus one standard deviation. So they want this area right there. What is that area? These are three numbers you need to memorize. Okay?
Okay.
Plus or minus one standard deviation equals 66% of the area. Plus or minus two standard deviations equals 95% approximately. And plus or minus 3 represents 99.4. So those are the three numbers you need to memorize. And as long as they don't ask you 1.5 standard deviations, then this is all you need to know.
Okay.
Okay?
So it doesn't matter
If they start splitting it up, then you've got to get a little more sophisticated and we got to go to the Z tables. Have they taught you about Z scores yet?
not yet.
Then they're not going to. So good.
Okay.
In other words, all of their questions are going to be 1, 2, or 3 standard deviations away from the mean. So,
Oh,
what's that area?
that's 34%.
Okay. And they might ask you a question like that. In other words, they might tell you that x bar equals 12, standard deviation equals 1. So what percentage of the curve lies between 11 and 12?
34.
Exactly. So
Okay.
all of their questions will be in terms of whole standard deviations, but they may not be as simple as the one you just gave me. In other words, what percentage of the curve lies between 1 or plus 1 or minus 1 standard deviation? They may say what percentage of the curve lies between the mean and 1 standard deviation below it, which is the blue area only.
Okay.
Okay? As long as you know these three numbers over here, you'll be able to answer any of the questions they're going to ask you at this level.
Okay.
Since they haven't taught you about Z-scores. That's the only way to handle those kind of problems, is with a Z-score. If they were saying, you know, what area lies less than 1.5 standard deviations, then you can't do it the way we just did it.
Okay.
All right, what else you got?
This one says to draw a binomial probability distribution histogram, and for guessing answers right on a 5-question multiple choice quiz.
I do not understand this problem at all yet.
So it's the binomial probability distribution for guessing answers right on a 5-question multiple choice quiz, and each question has 4 options. And it says find the probability of getting at least 2 answers right.
Okay. Now I understand it. Trying to figure out if there's a simple way to answer this or not. You have 4 questions?
5 questions with
5
4.
questions. Each one of them have 4 multiple choice.
Yeah.
So, what's the odds of getting exactly 1? No, what's the odds of getting none right? Let's start with the easy one.
Oh, is that 0 out of 5? No.
Well, what's the odds of getting the first question incorrect by guessing?
Is it 75%?
What's the odds of getting the second one wrong by guessing?
1/3.
No, still 75%. There's still 4 multiple choices. The only way to get it wrong is if you guess one of those 3.
Okay.
They're not correct.
Okay, I see.
On all your questions, what would the odds of not getting anything right by guessing be?
75%.
No, that's each one. If you didn't get any of the 5 questions right, it would be 75% times 75% times 75%, or this to the 5th power.
Okay.
Okay? So, if you were to guess on 5 questions, this is the odds that you wouldn't get any of them correct. And that's a pretty small number. Do you have a calculator?
Yeah.
What's 3/4 to the 5th power? Or 0.75 to the 5th power?
It's 0.237.
Yeah, which means the odds of you getting at least 1 correct are 1 minus that. Right?
Right.
And notice I said the odds of getting at least 1 correct.
Right. Okay.
Because the odds of getting none correct is this number. So the odds of not getting none are 1 minus that number. But that can be getting 1 correct, 2 correct, 3 correct, 4 correct, or 5 correct. And what they asked for specifically was getting exactly 2 correct, right?
Right.
That is a harder problem, quite a bit harder.
Oh, wait. No, it says at least 2, right?
At least 2.
Yeah.
And what does that mean on the other side? At least 2. So it rules out this, where you don't get any. And we know the odds of getting 1. The odds of getting 1 precisely? Let's look at that. I'm sure the answer to this problem is going to be some NCR. You know what I'm talking about?
Yeah.
Okay. But those are hard to come up with. I'm not even sure I can do it. But let's talk about what getting 1 would be.
Okay.
You would have to get the first one and then miss all the others. Right?
Yeah.
One way to get 1. In other words, 0.25 times 0.75 to the 4th power. So this is one way to get 1. But notice I can not get that one and I can get this one. So the odds of getting the second one only are this again. Same with 3rd, 4th, and 5th. So I know the odds of getting precisely 1 are 5 times that. There's 5 different ways I can get precisely 1.
Right.
Now, to get precisely 2. If we treat this as a counting problem, well, I can get 1 and 2, and I'm going to miss 3, 4, and 5. I can figure out the math on that. Right?
Yeah.
In other words, it's 25 times 25 times 75 times 75 times 75. But it could also be 1 and 3, where I miss 2, 4, and 5. Each one of them is the same percentage. So to answer this question is all we have to do is find out how many combinations there are. I know what the odds of getting precisely question 1 and question 2 is. It's 0.25 times 0.25 times 0.75 cubed.
Right, okay.
Here, let's go up. Let me have some room here. So 1 plus 2 is one way to get 2 correct. We know that that is 0.25 squared times 0.75 cubed. You can also get 1 and 3, same thing. 1 and 4, same thing. 1 and 5, same thing. There's 4 different ways to get 2 correct. You've also got 2 and 3, 2 and 4, or 2 and 5. And each of those is the same.
Right.
Am I losing you yet?
No, I get this, yeah.
Okay. And we also get 3 and it's got to be different. It can't be 1 because that's the same as this one up here.
Mm-hmm.
So it's 3 and 4 and 3 and 5. Same odds though. They're all 0.25 squared times 0.75 cubed.
Right.
There's one other combination. 4 and 5. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of them are this one, so the odds are 10 times that.
Okay.
So take 0.25, square it, multiply it by 0.75 cubed, multiply all of that by 10, and there's your answer. Now, I'm guessing that there's a pretty easy formula that you wouldn't want to have to count this out if it was 15 questions. In other words, let's say that they say, what's the odds of getting exactly 3 correct on 15 questions? Well, this is going to take you forever to do it the slow way, like I just did it.
Right.
But I think this comes out to be 5 taken 2 at a time. What would that be? 5 factorial over 2 factorial times 3 factorial, which is 5 times 4 divided by 2, that is 10.
Okay.
Okay, so you can figure out how many you have over here by this formula right there. but you still have to do the inside part. In other words, this gives you the 10, but it doesn't give you that and that. That you kind of have to figure out separately, I think.
Yeah.
So what this really is going to be is 5 choose 2 times 0.25 squared times 0.75 cubed times 5 choose 2. In other words, we get that 10 from 5 choose 2. So now if they gave us a question that, let's say there were 20 questions, what's the probability of getting exactly 3 right? Well, that's going to be 20 choose 3 times 0.25 squared times 0.75 cubed. So here's the quick and dirty method of doing it, regardless of how many or how big the sample is.
Okay.
Okay. Now, what I have found that a lot of times with these counting problems, it really is helpful to go through this analysis over here on the left. If you can do it. In other words, if it's small enough that you can go find out how many combinations there are. Precisely. But you will always find that it's going to be n choose 2 if, in this case, they wanted 2 correct answers. I think in this bottom case here, this number right here has to match the 3 down here, which means that has to be 2.
Okay.
Okay? So what it really is n choose r times the odds of guessing correctly to the r power times the odds of guessing incorrectly to the n minus r power. I don't know if you can see all that. Let me rewrite that up top here in blue. In other words, on any general problem, such as this, it's going to be since you're trying to get 3 correct, if it was, 20 choose 3, well, that's that. And the 1 minus, these two have to total 5 in this case. So this would be the odds of getting 3 correct.
Okay.
In fact, it would be this. If they said the odds of getting 3 correct instead of 2, it's that. If they said 4, then this would have to be a 4 and this would have to be a 1. Because to get 4 correct, you gotta do the 1/4 probability to the 4th power. Okay?
Okay.
So this is kind of the general formula for problems like this, where order doesn't really matter. When order doesn't matter, you're talking about a combination problem. Notice that order did not matter here. 1 and 3 was the same as 3 and 1, therefore I didn't even write the 3 and 1.
Right.
If they were different, then it'd be a permutation problem, and it would be 5 pick 2. If order mattered. In other words, if 3 and 1 were different than 1 and 3, were, uniquely different. But in this problem, it doesn't matter. They're just saying if you get 2 problems correct, well, if you got it correct on 1 and 3, that's the same as getting it correct on 3 and 1.
Okay.
All right. What else you got?
Um,
We have
let's see.
about 10 minutes, so choose wisely.
Okay.
We're going to be able to cover everything you want to cover, but that's why I say that.
Do you think we have time to expand the power of a binomial?
Yeah, we can look at that.
Okay, cool. All right, so it's 3x plus 2 in the parentheses, and then raised to the fourth power.
Okay. So we know right off the get-go that it is, what's that first coefficient?
Um,
And what that means is 4 choose 0.
okay.
In other words, it's n over 0 is the first coefficient.
Okay.
The first term on the left is 3x. What power is that going to be to?
Is that going to be to the fourth?
Yep. What about the number 2? What power is that going to be to?
The 0?
Yes. Key part of it is knowing that that's actually there, but it's to the 0 power, so we never write it. So this ends up being 4 choose 0 times 3x to the 4th. But that's the first term. What's the second term?
Is it 3 choose 1?
Oh, it's 4 choose 1.
Oh, okay.
And this is what?
That's raised to the third.
Yeah, this counts down, the 2 counts up. With me?
Yeah.
What's the third term?
4 choose 2, and then 3x raised to the 2 times 2 squared.
And the next term?
That's 4 choose 3, 3x to the 3.
Whoops.
Wait,
Oh,
that's to the 1.
right. First term counts down.
And then 2 cubed.
And the last term?
4 choose 4, 3x raised to 0, and then 2 to the 4.
And there's your answer.
Okay.
Now,
Cool.
it's worth knowing that 4 choose 0 is the same as 4 choose 4.
Okay.
Why? Because it's 4 factorial over n factorial, which is 0, times n minus r. So that's what 4 choose 0 is. Well, what's 4 choose 4? That's 4 factorial over 4 factorial times 0 factorial. Same number.
Okay.
Okay? So if they're asked, is that all they ask you to do is expand it fully?
Yeah.
Okay, well, I'm not sure that this qualifies as an answer. In other words, we have to convert that to a number. We have to convert that to a number. We have to convert each of those to a number. Now we probably should simplify the 2's by converting those to numbers. And then whether or not you need to cube or take 3 to the 4th power or not, I don't know. You might get away without having to do that. It's not that hard to cube it. In other words, the first term is going to be 81x to the 4th. See where I got it?
Yeah.
4 choose 0 is 1. 3 to the 4th is 81. What's the next term?
That would be
What's 4 choose 1?
Was that B1?
Well, it's 4 factorial over 1 factorial times 3 factorial. What's 4 factorial over 1 factorial times 3 factorial? 4.
Okay.
And the way these factorials work is that's 4 times 3 times 2 times 1, okay? Well, if I have a 3 factorial on my bottom, that's 3 times 2 times 1. You can cancel those out. So all I'm left with is 4 in the numerator and 1 in the denominator. So that's why that's 4.
Okay.
Okay? And so that would be 4 times what?
3x.
Expand.
No, what that?
What's 3x cubed?
That would be 27x.
And then there's still this 2. So what we really have is 8 times 27. So that coefficient is going to be 8 times 27 x cubed. That's going to be the second term. You with me?
Yeah.
What's 4 choose 2 for the third term?
That'd be 20. Would that be 8?
Oh, do it this way over here. You need to be able to do these manually, for sure. If we accomplish nothing else tonight, we need to show you how to do n choose r. Let me give you the general formula. N choose r is n factorial over n minus r factorial times r factorial. So what's 4 choose 2? It's 4 factorial over 2 factorial times 2 factorial. What's that? One of those 2's takes out the 2 and the 1. So now we have 4 times 3 divided by 2. What's that number?
That would be 4 times 3.
Now let me just be clear here, because I'm sensing you're not totally getting this.
Is that 6?
It's 6. Is that what you said?
Yeah.
Here's what we're dealing with. There's 4 factorial in the numerator and 2 factorial twice in the denominator. Well, one of these takes out that. So what I'm left with is 12 divided by 2.
Right. Okay.
So that is 6. What's the rest of it? In other words, 6 times what?
That'd be 9x squared times 2 squared, which is 4.
There you go. Multiply those 3 together and you have your third term.
Okay.
Fourth term. Turns out that 4 choose 3 is the same as 4 choose 1. So that number is 4. Times 3x times 2 cubed. And finally, the last term, 4 choose 4 is 1. 3x to the 0 is 1. So the last term is just 16. So fully expanded, we have that as our first term. Whatever that simplifies to is our second term. Whatever that simplifies to is our third term, fourth term, fifth term is just 2 to the 5th.
Okay, cool.
Hold on, 2 to the 4th rather. Sorry.
Yeah.
Which is 16. Yeah. 2 to the 5th is 32. So that's the way you do a binomial expansion. And this thing in front of the 3x is always a choose. In other words, it's 4 choose 0 and then it counts up. 4 choose 1, 4 choose 2, all the way up to n choose r. Starts out as n choose 0, and then n choose n minus 1, so forth and so on. In other words, it follows this pattern.
Okay, cool.
Okay. Jake, that's the end of our session. You have any questions? The last final questions you'd like answered before your test?
I think I got it.
Okay. Sorry about my dog.
No, that's fine.
Okay. I'll talk to you later.
All right, thank you.
You're welcome. Bye-bye.
Bye.